Hey guys, we're going to do notes today over parametric equations. We've been talking about equations mainly that are in the form y equals f of x, where y is just a function of x. And so that you only have one equation and you have an x and a y. You know that it's a function if it passes the vertical line test. But we've been talking about over the last unit other types of graphs like conics where you have a parabola or an ellipse or a circle. And those are definitely not functions because they don't pass the vertical line test. So they do have a set of points though. They have a collection of points on the xy plane where you have an x and a y. That doesn't mean it's a function, but they still have points that would make the graph. Well, what we're going to do today is talk about, we're going to find a way to graph this in our calculator for one thing, but we're going to be doing something called parametric equations where we have a parameter. You're going to take the x, you're kind of going to look at it horizontally and you're going to look at it vertically. So you're going to do, see how x relates to like a function of time and how y relates to something with as the function of time. And these are called parametric equations. So looking at this graph over here, we can see like this path of this curve right here. Usually we put these little arrows on it to show the path over time, how it actually followed through that curve right there. All right, let's do some actual examples. Okay, what we're going to first do is we're going to do this by hand, and then I'm going to show you how to do this on your calculator. So by hand, we've been given this set of parametric equations right here. So you'll have one equation, x is equal to 3t squared. So t is our parameter, and y is equal to 2t. And so now we can see what it does horizontally and what it does vertically. And they've also defined for us what the domain is. So what you're going to do is you're going to set up a table. And we're going to do the t's from -2 to 2. And we're going to see what x and y is. So I'm going to plug in into the x equation. I'm going to plug in -2. So I'll do 3 times -2 squared. And I get 4 times 3, which is 12. Then I'll do 3 times -1 squared. And I get 3. Then I'll do 3 times 0 squared. And I get 0, and etc. Then I'm going to plug in the t into the y equation. So I'll do 2 times a -2, which is a -4. 2 times a -1, which is -2. 2 times 0, which is 0. 2 times 1, which is 2. And then 2 times 2, which is 4. Okay. Now then what you're going to do is you're going to graph these x and y's that you got. So over here, we're going to go and graph 12, -4, right here, 3, -2, 0, 0, 3, 2, and 12, 4. Okay, so we started at this point right here, and then we went to this point, and then this point, and then this point. This was the path that we made. So we have to put these arrows on our path so that we show the path that we took. Now I'm not going to put an arrow right here because I didn't go forever. I stopped at those places because they gave me this domain restriction. All right, I want to show you now how to do this on your calculator. So I'm going to see if I can, let's see, hang on one sec. Okay, so I'm going to try to show you, this is like a big TI-84 calculator, and I'm going to try to show you the steps that we would do on your calculator. So the first thing you're going to want to do is to change the mode. So if you'll notice right here next to the second button's the mode, you're going to go to your mode on your calculator, and you're going to want to make sure you're either in degrees or radians, and you're going to make sure, normally we're in function mode. You're going to want to change it to parametric mode because that's what, it looks a little different when you push it on your TI-84, but basically you're changing it from function mode to parametric mode. Okay, when you do that, and you go to your y equals, it looks a little different. Instead of just saying y equals, now it says x equals and y equals because we're going to put in our parametrics. And then on that example we were just doing, our equations were x equals 3t squared. Oops. Let's see. 3t. So you use this button right here next, the button on the right of alpha. It says x, t, theta, and n. If you type that, it'll type in t here. So you're going to do 3t squared. And then into y1, you're going to type the other equation, which is just 2t. Oh, keep doing that, sorry. 2t. And then we're going to go over here in my window. I'm going to, now you, instead of just having an x-min and an x-max and a y-min and a y-max, we have a t-min and a t-max. And our t-min needs to be -2 based on the domain restrictions they gave us. And our t-max needs to be +2. Now, if you're doing just from -2 to 2, you can leave your t-step at 0.1. When we change it to where it's angles, we're going to make it a little bigger than that so it doesn't take it forever. I know my x max needs to be bigger because when we did our table, we got it as high as 12 for the x's, so I'm just going to make that a 20. And then I'm going to go over here and I'm going to graph it. And it graphed exactly what we did on our by hand a while ago as well. The only thing is it doesn't show you the arrows or anything, but let's see if I can show that on here. We would just want to make sure we put these arrows on here to show the path that it took. But that's how you would do this on your calculator. I'll try to go back and forth so we can see that better as we do our examples. Okay, let's do the next example. Okay, on our next example, we have, our directions. What they're asking us to do is find the rectangular equation for the curve defined parametrically. So basically what that means is that you're going to go from parametric to geometric, to rectangular. Sorry about that. Which means you're going to have one equation with x and y. Oops. All right, so right now we have two equations. We have an x equals 1 over square root of t and y equals 2 t squared. You're going to want to solve one of those two equations for t. It doesn't matter which one, but usually I choose the one that's a little easier to solve. I can just switch these two, so that becomes the square root of t equals 1 over x. And then I'm going to square both sides. So show that work. Okay, so when you square both sides, you're left with t equals 1 over x squared. You square the top and the bottom of that fraction. Okay, so now I'm going to plug that in for the t right here. So we're going to say y equals 2 times 1 over x squared, and then that whole thing is squared. So all I'm doing is I'm plugging it into this equation, and I'm doing the operations that that's said to do to t, which t was 1 over x squared. Okay, when you simplify that, you get 2 times 1 over x to the 4th, and then that would be 2 over x to the 4th. Okay, so that is the rectangular equation that if I just graphed it on the normal function mode, it would give me the same graph that these would give me in parametric mode. Okay, then we need to talk about what the domain of that function is. So one thing you should consider is the fact that you cannot divide by 0. That's not okay. So whenever we do our domain restrictions, we're going to say it's all real numbers, but x cannot equal 0. Or another way to write it would be -infinity to 0, and then union 0 to infinity. All right, let's do the next one. So on the next one, we have, let me just do this. We have these two parametric equations. I'm going to probably solve this one for t because it's easier. So t equals 2 times y. And then I'm going to plug that in for t here. So it'll be x equals 2y squared minus 4. All right, and then you're going to want to solve this for y, because we normally have a function equation or a rectangular equation in terms of y. So the first thing you're going to want to do is move over the 4. Remember, when you're solving an equation, you undo your order of operations backwards. So you undo any adding and subtracting first. So we're going to add 4 to both sides. And then I'm going to go ahead and square that 2y, so that becomes 4y squared. Then the next step after undoing the addition is we're going to undo multiplication. So that will become x plus 4 divided by 4 equals y squared. And now we can undo the squared, which means that we need to take the square root. But remember, when you take the square root, you have to do plus or minus. So that'll be plus or minus the square root of x plus 4 over 4 equals y. And then technically you're not supposed to have a fraction under a radical, or you're not supposed to have a radical in the denominator. And so we're going to take the square root of the top and the bottom. So we get plus or minus the square root of x plus 4 all over 2 equals y. And that is our rectangular equation. Now, on the previous example, they asked us what the domain restriction was for that. If I were going to do the domain restriction for this one, I have to be concerned about the fact that I have this under a radical, and you can't have a negative in the radical, so we know that x plus 4 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 4. So that would be my domain restriction for that one. All right, let's do the next example. Okay, on this one, we have these parametrics here. And again, they want us to find the rectangular equation of the curve defined parametrically. A while ago, I forgot to bring up the fact in those directions that it told me that it wanted me to eliminate the parameter. No, sorry. Eliminate the parameter, which basically means get rid of the t and get it in terms of x and y. It means to just get one equation in terms of x and y. All right, so we've got x equals a cosine of t. We have y equals a sine of t. Now, a is just some number. It's a constant. They're just calling it a, but what we're going to do is isolate the cosine of t and the sine of t. So we're going to divide by a on both of those. So we'll get, y over a equals sine of t. And then I want you to remember this identity, cosine squared of t plus sine squared of t equals 1. And then I'm going to plug this in for cosine, so that'll be x over a, and we're squaring it, plus plug this in for sine, so y over a squared equals 1. So I'm going to go ahead and square those. That's x squared over a squared plus y squared over a squared equals 1. And if you'll notice, this looks a lot like our conic section that we just quizzed over. This has an x squared and a y squared. They're both being added. The number on the bottom is the same, so that makes this a circle. And I can make it look like a circle equation if I multiply both sides by a squared. And when I do that, that becomes x squared plus y squared equals a squared, which means that I have a circle with a center at 0, 0, and the radius equals a. So if you were actually to graph it, you have a point here at a, that's at a0, this is at 0a, this is at negative a0, and this is at 0, negative a. And if you start at angle 0, you're going to end up going this way. And the path that would be taking is this path. And that would be our graph for this one. Okay, I wanted to kind of show what that looks like when we graph that. Let me clear this out. So we just did a cosine t. I'm going to make a just a number like 5. So this, I'm going to say this is 5 cosine t. And then my y will be 5 sine t. All right, before I graph this, oops, I need to change my window. So this time I went from negative infinity to infinity, but we're talking about cosine of t and sine of t. So I'm just gonna do it 0 to 360. I'm in degrees. So I'm gonna keep that. And that's what t represents. It represents our angle. So I'm gonna go from 0 to 360 degrees. I'm going to change this from a t-step of 0.1 to just 1 because that's going to take forever. What it does is it does a step every 0.1 angles, and so that's going to take you forever from 0 to 360. Let's see. I really don't need an x min and max like that. I'm going to make this 10. Make this back to negative 10. And then make this back to negative 10. To 10. All right, now let's graph this. And so that shows us it's a circle. It looks like an ellipse. What I need to do is go back. I'm going to do the zoom. I'm going to square it up. I mean, on your calculator, that's zoom 5. But if I square it up, you can see that it looks like a circle. And it's a circle with a radius of 5. All right, let's go back and to our examples. Okay, on this next example, I'm going to do a over here. I'm going to say, this is x equals x equals a cosine of t, and then y equals a sine of t. And they want us to this time to do it from 0 to pi. So I'm going to do a little table. I'm going to do t, x, and y. And I'm going to just do it. I'm just going to do the quadrantals because we're going to kind of be thinking about our unit circle where this is 0, this is pi over 2, and this is pi. This is the ordered pair 1, 0. This is the ordered pair 0, 1. And this is the ordered pair negative 1, 0. And so my t represents the angles because it's cosine of t and sine of t. So I'm just going to do those quadrantals from 0 to pi, since that was the domain restriction right here that they gave me. So when I type in 0 for I do cosine of 0. Remember, that's the x value on the unit circle there at 0, so it's 1. So I'm doing a times 1, which is a. And then I'm going to do a times sine of 0, which would, sine of 0 is right here. It's 0. So a times 0 is 0. When I do a times cosine of pi over 2, I'm going to get a times 0, which is 0. When I do a times sine of pi over 2, I get a times 1, which is a. When I do a times cosine of pi, I get a times a negative 1, so a negative a. And when I do a times sine of pi, I'm going to get a times 0, which is 0. So basically, you've got a point right here at a0. You have a point right here at 0a. And you have a point over here at negative a0. And so you should see that you just have a half circle. It started here and it went in this path. On the next one, we have x equals a negative a sine of t for the x, and for the y, we have a negative a cosine of t. Again, we're doing it from 0 to pi, so I'm going to do another table. And I'll do the quadrantals again. And I'm plugging in those t values to the angles for each of these. So for the x equation, I'm plugging in a negative a times sine of 0, which will be 0. And then for the y one, I'll do negative a times cosine of 0, which will end up being negative a, because you're doing negative a times cosine of 0, which is negative a times 1, just to make sure y'all know what I'm talking about. Then I'm going to do negative a times sine of pi over 2, which will be negative a. And then negative a times cosine of pi over 2 is 0. Negative a times sine of pi is 0. And negative a times cosine of pi is negative 1. So negative a times negative 1 is a. So this time you have a point here at 0, negative a. You have a point here at negative a, 0, and you have a point here at 0a. So this time you've gone on this path. You started here and you went this way. So those are just two different parametric equations with those domain restrictions graphed. Okay, this one is very similar to the earlier example we did, but we're going to, again, graph and find the rectangular equation. So I'm going to first graph it or do a table. And I know it says negative infinity to infinity, but I don't need all of those numbers, obviously. So I'm just going to do -1 or -2 through 2. And when I plug that in, I get 12 and then 3, 0, 3, and 12. When I plug in those numbers into the y equation, I get -6, -5, -4, -3, and -2. All right. And again, these are the numbers I'm going to graph over here. So at 12, we're down here at -6. At 3, we're at -5. At 0, we're at -4. And then -3. And then 12, -2. Okay, this one does go forever because it's negative infinity to infinity. So it looks like this. And really, I mean, I guess we should be showing our path, so it should be like this. All right, so now it also said to find the rectangular equation. So I've got these two equations right here. I'm going to solve the y equation for t. So I'm going to move the 4 over, so I get y plus 4 equals t. And then I'm going to plug that into t right there. So x equals 3 times y plus 4, the quantity squared. All right, now, if you'll remember, when you have a parabola that's facing left, we would have the part that's squared, the letter that's squared on a side by itself. I'm going to divide or multiply both sides by 1/3. So multiply both sides by 1/3. That way this side will cancel right there, and I will have 1/3 x here. So the fact that we have the y that's squared, that tells me that it either opens left or right. It's a parabola that opens left or right. The fact that my p value, that's my 4p, 4p equals 1/3. Because it's positive, I know that it's opening to the right. P equals 1/12 here, if I figured out my focus and all that stuff. Well, first of all, I know my vertex is at 0, -4, which we see graphed right there. I could figure out my focus. It's 1/12 units away, and then you could do your latus rectum and all that and graph this as well. But this would be my rectangular equation in standard form for the parabola. I could solve it for y as well, but honestly, that's probably the best for us right now. All right, let's do it some more. Okay, on this example, they're asking us to find the parametric equations. So they've given us the rectangular one, and we're going to parametric. So we should have two equations, an x equals equation and a y equals equation. And this is the original rectangular equation that we're starting with. They want us to substitute x equals t, so that's our first equation for the parametric. And all we're going to do is plug in this t in for the x right here. So the y equals equation will be y equals t squared minus 4. And those are our parametric equations. Now we're going to do the same thing. This time they want x equal t cubed. So again, my equation that I started with was y equals x squared minus 4. I need y in terms of t. So I'm going to replace the x with t cubed. And then you're going to do all the operations to it that I was doing to the x before, which is squaring it and subtracting 4. So that'll end up being y equals t to the 6th minus 4. And those are my parametric equations for that. Okay, on this one, they've given a graph, and you can tell it's a parametric graph because they have these little arrows right here. And they want us to write the parametric equations for these. So I already know that I'm going from 2 to 7 for my x values. What I'm going to do is, you're going to need an x equals equation and a y equals equation. I'm just going to make x equal t. That'll be the easiest for me. And so now I've got to figure out the y equation. So right now I know that I've got the, think of writing the equation of a line. I've got a point. I've got 2 points actually. Right here, I'm going to make this my point 1. So this is my x1, y1 that I'm going to plug in for these places right here. And then I just also need to know the slope. Remember to get the slope is change in y over change in x. Well, if I'm going to go from 0 to 5 vertically, let's see. Vertically, I go up 0 to 5. That's going up 5. And then I go to the right from 2 to 7. That's going to the right 5. So my change in y over change in x is 5 over 5, which means my slope is 1. So now if I plug those numbers in, I've got y minus that point that I chose to use was the 2, 0. So 0 was the y. My slope was 1. And then I'm doing x minus 2. And then solve that for y. I get y equals x minus 2. Which we are going to use the t value. Because remember, x is the same thing as t, so it's going to be y equals t minus 2. And that's my parametric equations. All right, on the next example, we see we have an ellipse here. And if you remember when you write the equation, if you have an ellipse, in this case, the center is at 0, 0. I have an a value of 3 and a b value of 2 because I've gone over horizontally 3 and then I went up vertically 2. So if I were to write this, a rectangular equation for this, it would be x squared over, because this is horizontal, the 3 is going to go under the x, so x squared over 9 plus y squared over 4 equals 1. All right, I need to change this to a parametric. Oops, sorry. I accidentally made that too big. Hold on one sec. Okay. So we're going to think again about our Pythagorean identity, cosine squared plus sine squared equals 1. So that is going to go in for cosine squared. So it'll be x squared over 9 plus this is going to go in for the sine squared. So y squared over 4 equals 1. And then think of that as x over 3 squared plus y over 2 squared equals 1, which means that cosine of theta equals x over 3. I did not write that very well, sorry. That equals x over 3, and sine of theta equals y over 3. So solving that for x, I'll get x equals 3 cosine theta. And solving this one for y, I'll get y equals sine theta. And those are my parametric equations. 2 different equations, one with x equals and one with y equals in terms of, and with a different variable there. So we use theta this time. You could have used t. But those are 2 parametrics. So these next few examples are just showing parametrics as conics. This is actually going to be a circle, this graph, because you've got a cosine theta and a 2 sine theta, and we have the same number in front. Well, that number just means to me that I have a radius of 2. And the fact that I'm not adding anything to cosine or sine tells me my center is at 0, 0. But let's just show that by eliminating the parameter. So I have that first equation, x equals 2 cosine theta. I'm going to isolate this by dividing by 2, so I'll get x over 2 equals cosine theta. On your other one, you had y equals 2 sine theta, and so you'll divide by 2 and get sine theta equals y over 2. And then you're going to remember your Pythagorean identity, cosine squared plus sine squared equals 1. So that'll be x over 2 squared plus y over 2 squared equals 1. So that's x squared over 4 plus y squared over 4 equals 1. And then I'm going to multiply both sides by 4, so that gives me x squared plus y squared equals 4. So what that means to me is that I have a center at 0, 0, and I have a radius at equal to 2. So if you were to graph it, you'd start here. You'd choose a different color. So you would just graph it like this. And that's our circle with a center of 0, 0 and a radius of 2. And I'm going to show you that, let's go ahead and do the next example actually. Let's see. Okay, this next one, this is going to be an ellipse, and that's because you have different numbers in front of your cosine and sine. I still have a center at 0, 0 because nothing's being added or subtracted there. I know this is a horizontal one though because I've gone that, this is telling me my A value is 5 and my B value is 3. So it's going to end up looking like this. Horizontally from the center right here, I'm going to go over 5. So you'll have that, and then you're going to go vertically from the center 3 on either side. And this should be your graph. So that's our ellipse there. But again, we can eliminate the parameter and see that in the normal conic standard form that we're used to. I'm going to divide by 5, and that's what equals cosine theta. And then I'm going to divide by 3, and that's going to be what sine theta equals. And then we're going to put it in the Pythagorean identity. So that'll be, I'm going to go ahead and square that. So that'll be x squared over 25 plus y squared over 9 equals 1. So again, you can see that you have an elliptical standard form equation with an a value of 5 and a b value of 3. Okay, on the next one, if you notice the difference between number 7 and number 8. Number 8 now has a number that's being added to and subtracted from the cosine and the sine, which means that your center has changed. So now I know my center is at 1, negative 2. When we did the conics last unit, we were talking about how, like you would have, you always use the opposite sign for your center, but when you're in parametric equations, it is the center. So my center is going to be at 1, negative 2. Horizontally, I'm going to go over 3 based on that number there. So 1, 2, 3 on either side. Vertically, I'm going to go up 4 and then down 4. So this is going to be our ellipse right here. Oops. Now I'm going to show you parametrically, or eliminate the parameter and make it a rectangular equation. So remember, when you solve an equation or you try to isolate, like I'm going to try to isolate that cosine theta, I've got to undo my order of operations backwards. So I'm going to subtract the 1 first, then I'm going to divide by 3, and then I'm going to do the same thing over here. So y plus 2 equals 4 sine theta. And then y plus 2 over 4 equals sine theta. And then when you write the rectangular equation, it's going to be, we're going to put it in our Pythagorean identity. And we're going to say x minus 1 squared over 3 squared, which is 9, plus y plus 2 squared over 4 squared, which is 16, equals 1. And then you can see you have, again, a center at 1, 2. You have an a value of 4 and a b value of 3. Because the a value is under the y, we know that it's a vertical ellipse. And now this has the equation with the parameter eliminated right here. All right, on number 9, they want us to write the parametric equations. We have the rectangular equation. So what you're going to do is, again, think of that Pythagorean identity. That was x over 3 squared plus y over 7 squared equals 1. Remember, our Pythagorean identity was cosine squared plus sine squared equals 1. Well, what that means is that cosine theta equals x over 3. So 3 cosine theta equals x. And sine theta equals y over 7. So 7 sine theta equals y. And those are our parametric equations. On number 10, again, we've got x minus 2 over 3 squared plus y plus 5 over 7 squared equals 1. Remembering that this is cosine squared theta and this is sine squared theta equals 1. So x minus 2 over 3 equals cosine theta. So we're going to multiply by 3 first. So x minus 2 equals 3 cosine theta, which means that, I'm going to write it over here, x equals 2 plus 3 cosine theta. So that's one of our parametric equations. And then we get the other one from y plus 5 over 7 equals sine theta. So y plus 5 equals 7 sine theta, which means that y equals a negative 5 plus 7 sine theta. And that's our other parametric equation. All right, one more example. All right, on this one, again, they want us to find the parametric equations. This is our cosine squared theta, and this is our sine squared theta, equals 25. But we need it to equal to 1. So we're going to rewrite this as x plus 4 squared over 25 plus y minus 1 squared over 25 equals 25 over 25. Basically, I've divided everything by 25. That way, we have it equal to 1, like we need it to, so it matches this, which means that we've got x plus 4 over 5 squared plus y minus 1 over 5 squared equals 1. So, cosine theta equals the first one. So we'll have 5 cosine theta minus 4 equals x. And you can write it like that, or you could have written it as negative 4 plus 5 cosine theta. And then over here we've got sine theta equals y minus 1 over 5. So that'll be 5 sine theta plus 1 equals y. Or again, you could write it as 1 plus 5. That does not look like a 5. 5 sine theta equals y. But these are my parametric equations. That one was equal to x. All right, so that's it for our notes today. Thanks, y'all.